Welcome to EduPorm EdTech. You're watching expert chemistry lectures with Abhinav Gaur. In this lecture, we will study different methods for the preparation of colloidal soap. In the previous lectures, I discussed that there are two types of sols, lyophilic and lyophobic. Lyophilic sols can be formed readily, but the lyophobic sols cannot be formed easily and readily. So, these methods are basically for the formation of lyophobic sols, which are irreversible in nature and which required certain special process for formation. So first we have chemical method. Colloidal solutions can be prepared by chemical reactions leading to the formation of molecules by process like double decomposition, oxidation, reduction or hydrolysis. So for example, I have a molecule A which is of the size of less than 1 nanometer. It is of size of less than 1 nanometer. Now this molecule will form true solution. But let us suppose we performed a chemical reaction like double decomposition, oxidation, reduction or hydrolysis, and this A molecule changed into AB by the chemical reaction, and now this AB is of colloidal range, that means 1 nanometer to 1000 nanometer, and now it is forming colloidal soap. Okay, so example of this is, for example, we have this AS2O3. I am reacting this AS2O3 with 3 molecules of H2S, and by double decomposition I will get AS2S3 plus 3H2O. So here O is taken up with this H and S is taken up with this AS. So now the form molecule AS2S3 is of colloidal range and it will result in the formation of sol, whereas AS2O3 will result in formation of true solution. So by means of double decomposition, I changed a true solution molecule into a colloidal range molecule. There are some other examples also, like SO2 which is reacting with H2S. We have AuCl3 which is reacting with formaldehyde, that means HCHO. We have FeCl3 reacting with water. So by means of chemical reactions we can also convert the true solutions into colloidal soap. Then we have electrical disintegration or Briggs arc method. In this process, dispersion as well as condensation. This process involves dispersion as well as condensation. Colloidal sols of metals such as gold, silver, platinum, etc. can be prepared by this method. In this method, an electric arc is stuck between electrodes and metals are immersed in dispersion medium. So what we do is, this is our metal of interest and this is also our metal of interest. For example, it is platinum. So I connect one rod with the positive terminal and another rod with the negative terminal. Now when I dip it into the dispersion medium and touch them, a spark will produce, and that spark will result in release of atoms from these electrodes, and those atoms or molecules will be of the size of 1 nanometer to 1000 nanometer, so they will form colloidal soap. This process is carried out in ice bath to control the temperature. Now the next method is peptization. Peptization may be defined as the process of converting a precipitate into a colloidal sol by shaking it with the dispersion medium. Okay, so what we have in precipitate, for example, this is a test tube. The precipitate will settle at the bottom and on the upper side we will have the liquid. So when we shake this, we will get a colloidal sol. The electrolyte used for this purpose is called as peptizing agent. If we are adding electrolyte, the electrolyte will be called as peptizing agent. The method is applied generally to convert freshly prepared precipitate to colloidal sols. During peptization, the precipitate absorb one of the ions. Okay, we add electrolyte. Okay, opposite electrolyte generally. So during this method, during peptization, the precipitate absorbs one of the ions of electrolytes on its surface, and this causes development of positive and negative charge of precipitants, which ultimately break up into smaller particles of the size of colloidal range. So these are the methods for the preparation of colloidal sols. So we studied three methods: peptization, electrical disintegration, and chemical methods. Thank you.